back. So in the last video, we started to talk about sprinkler systems and how they're tied into the fire alarm panel. Or I guess the better way to say it is they're monitored by the fire alarm panel. And I kind of explained some of the devices, but we haven't done any of the wiring yet, and we haven't really looked at how they're tied into the panel. So the two devices that I talked about so far were valve tampers and water flow switches. So here we have a 4-zone panel, and we're going to connect it to the water flows and valve tampers. And there's a couple different ways that you do that. It depends on what type of panel you have, and another important consideration is how your fire alarm system is being monitored. So if you look at this panel, it looks a lot like one we've used in past videos, but I added something down here, and it's another set of contacts, it's another relay, and that's a supervisory relay. So one thing that can be confusing for newer technicians or people that are new to fire alarms in general is the difference between supervisory and supervising a circuit. We've talked about end-of-line resistors, right? When we have smoke detectors or heat detectors at the end of the circuits, we had a resistor, and that was to supervise the circuit. So if it were open, we'd know that it was open, right? I mean, the panel's designed to know how much current should be flowing through a circuit, and if there's an open circuit, it causes a trouble, and that's called supervising. Well, there's also supervisory signals, which it's basically the definition of it would be it's a signal, it's a condition on a panel it's an off normal condition on a panel that's different from a trouble, and it's different from an alarm. So it's just a different category of signal, and it's usually used for valve tamper switches. And when I said that it's important to know how you're sending signals to the fire department, if you remember when we did reverse polarity, the module for that, there is a way to kind of loop that through your supervisory contacts on your panel, but it's not always done correctly. I guess I should say I've seen panels where a valve tamper will be set up for a supervisory signal, but the communicator has no method of sending that signal to the fire department. So you could close the valves and it would cause a supervisory condition on your panel, but it's not going to ever tell the fire department. So it's something to keep in mind, and it'll make more sense once you get more familiar with all this. But so the supervisory, if your panel has supervisory capabilities, then that means that there's typically you're able to program the panel in certain ways. Most conventional panels, there's not a lot of programming done, depending on the type. The type that I've drawn here, they're so basic that there's not usually any programming to be done. But let's assume this one can be. And so when I say programming, there's a lot, especially with addressable panels, there's a lot you can do with programming, and I don't want to get into all of it right now. But basically, you could tell the panel that one of these zones is going to be a supervisory zone. So let's say that I could program this panel. There's different ways to do it. Totally depends on the manufacturer of the panel, the model of the panel, etc. But let's say that I could tell the panel that zone 1 here is supervisory. So when this goes into, like when this zone is activated or shorted, it's not going to cause an alarm. It's going to cause a supervisory. And then instead of the alarm relay changing states, the supervisory relay would change states. So hopefully that makes sense. Let's say that I've already done that. I've gone into this panel and I've programmed it for supervisory. Hopefully that's an easy enough idea. So that the reason that you have to know that ahead of time is it changes how you're going to wire the valve tamper. So if this is set up for supervisory, we're going to wire this just like we would wire any smoke detector. We could go, and this is, I'm assuming here that these contacts are internal on the device that's monitoring this valve tamper. I know I didn't draw one, but hopefully I've explained that good enough in the previous video where you understand that this would be internal on the device that monitors this valve. So now I'm just drawing it like a set of contacts because that's what would be on there. So now we have positive to positive. I'm sorry, positive to common. Oh, nope, I did this wrong. Positive to common, and then we're going to go negative to normally open. And our panel still needs a resistor because we still need to know if something happens to the circuit. So that was off a little bit. So now we draw a resistor. That was horrible. Let me redo that. And again, that's a symbol for the resistor. So, the current's just flowing through the resistor. If you started to close this valve, at some point, this would change states and short out. But since we've already programmed this zone as supervisory, it's not going to cause an alarm. It's going to cause a supervisory, and this relay would change states. If zone 2 is set up for alarm and it's our water flow, then that's, pretty straightforward. We're going to do the exact same thing. Go here. And, positive and negative don't matter because it's not actually powering anything up. I did it wrong again. We're going to normally open, and we're looking for a short, right? So it's a pretty straightforward idea. But let's say that the panel doesn't have this supervisory relay. I hope I can undo this many. Yes, I can. Good. Let's say we don't have this capability. Let's say we're going to make our valve tampers a trouble signal, and maybe we want to keep it on the same zone. Maybe we're limited on zones and we don't really have a choice. We have to do it that way. I mean, typically you'd have your own zone for, even if you're making this a trouble, you'd have your own zone. But let's assume that we're going to share the zone. First, you'd have to go to the water flow switch, and I'll explain why. But let's start with, let's say zone 1 is our, now we didn't program it for supervisory, now our panel doesn't have that capability. You would go, well, we'll go to common first. Let's go positive and negative to common normally open on the water flow. So when this activates, when water starts flowing, it's going to push this paddle and change the states of these two. There's two sets of contacts. There's usually two sets on the tampers as well, but we don't use those. On the water flow, we are going to use those, and I'll show you how in a minute. So now we need to also go to this tamper. Now we're going to come right back out of here. And if the tamper is going to cause a trouble, instead of going common normally open, now we're going to series through here. So we're going to come out of normally open. Oops, wrong color. Out of normally open. And I'm going to leave it here for now. We're going to put our resistor in series here. And if we follow, if we follow the current, let's see what happens. We're going to go through. We're going to go negative to the flow and back out, right? It's not going through those contacts. It's going back out. We're going through our resistor, through the relay on the tamper, and then back to the panel. So there is current flowing. We have a complete circuit there. And I know this is kind of sloppy, but it makes sense. If the water starts flowing, if one of these sprinkler heads bursts and then water starts shooting out of here, this flow is going to activate, which will short. And if that hadn't happened and somebody had closed this tamper, then it's going to change the states here, and it's going to open this circuit because this little, the little armature here is going to go over to normally open, and it's going to open up our circuit. We're going to get a trouble. And the reason you always go to the water flow first is if this were closed, let's say it was closed partially, because if it was closed all the way, I guess the water flow is not going to activate anyway because there's not going to be enough water. But let's say that this was closed a little bit, enough to open up this circuit. Well, if we had gone here first and then went to our water flow, once that circuit opens, we're never going to get our alarm. So we always need to go to our water flow first so that it'll short out and then come out and go to the valve tamper, and we put our resistor in series. Hopefully that's an easy enough idea. I want to go back to the supervisory idea though, just real quick. We don't need to spend a lot of time on this, but I copied the dialer that we had looked at in a couple videos ago, and the first few times I did it, we only used zones 1 and 2, right? We did alarm and trouble. Well, usually when you have supervisory, you'll use that zone 3 for supervisory. So I mean, this is pretty simple. It's pretty straightforward. But it's something I hadn't mentioned before. So now that we have another signal, we need to have a way to send it, and I can go in and program this dialer and tell it that zone 3 supervisory, so when it sends it to the dispatch center, they'll know that if one of these valves is shut, or sometimes duct detectors are programmed for supervisory. So I think that's pretty straightforward. And then there's a resistor, and again, the resistor is for the dialer, right? I mean, if this is a little confusing, go back and watch the video on the dialer, but there's a resistor on these contacts, which is what's supervising this dialer. It's not supervising, the panel doesn't supervise its own relays. It doesn't care if you use them or not. But then if you had a valve tamper activate, you're going to short out this supervisory relay and so on. And then we would have to hook up 24 volts power to this as well. The last thing I want to the last thing I want to show is a sprinkler bell. It's pretty common. Um, Actually, I mean, pretty much every building, it's code. It's a requirement. Every building is required to have a sprinkler bell if you have a sprinkler system, which activates when the water flow is activated. And the way they do that is pretty simple. So let me bring this into the picture. Um, okay, so what do we have here? We have a this is the sprinkler bell up here, and this is a breaker box, like I had drawn in the video when we did I did a light switch when I was trying to show you what a relay was. And if you don't know much about AC circuits, don't worry, at some point we're going to get into that. But here's our little neutral bar. So let's say we need this bell to ring when the water flow is activated, right? It's going to work just like a light switch or just like any of our relays. We're going to take neutral out of our neutral bar, go right to our bell. We're going to take the hot circuit from whatever open circuit breaker we have. So we'll have the the line comes into the breaker box and then it distributes it. And we're going to take our hot to common, and then we're going to come normally open to this bell. So when this switch activates, when the water flow activates, now our current can flow to the bell. And this is not supervised. So if this were popped, if this breaker popped, or if a line was cut, you'd never know it. It's why it doesn't have to be supervised, I'm not really sure, but that's just the way that it's always set up. So hopefully this all makes a lot of sense. I don't think any of it's too groundbreaking. None of I know that it was a little confusing the way I drew some of this stuff, but it's something that we'll see a little bit more because we're going to talk about dry sprinkler systems, which are systems that don't have water in them at all times. There's water that's kind of held back waiting to be activated. So we'll get into that. So we'll kind of go over a tamper again, and I guess that's it for right now, and I'll see you in the next video.